Good evening, everyone. Johnny Camps, let's start off. Hope everyone's tried the homework problems. What is the answer for this? Anyone got it? Let's see how to do. So, few things. First of all, you should know little information about a cone. So, if you have a cone here, let this be R, this is H, and this is L. What is the volume of the cone, everyone? What is volume of the cone?
1 by 3 pi r square h.
1 by 3 pi R square H. Okay. But now in our information, if you see in the question, there is no R anywhere. There is only H and L. Agreed? So from here, I need to eliminate that R basically. So L square is nothing but R square plus H square, Pythagoras. So R square is L square minus H square. So that means I can write this thing as 1 by 3 pi L square minus H square into H. Are you getting the logic there? So the thing is, if the question has everything in terms of L and H, why are you talking about radius? So eliminate radius. Fair enough. So we got volume is 1 by 3 pi L square H minus H cube. One. Second thing, this angle is given 60 degrees. That means what is the relation between L and H? L cos 60 is equal to H. That means H is equal to L by 2. Fair enough? So in our formula here, so V is equal to, or let's say L is equal to 2H. Substitute here. So V is equal to 1 by 3 pi. L square is 2H whole square. H minus H cube. So this is 1 by 3 pi. That is 2 square. So 4H cube minus H cube. That is 3H cube. So that becomes pi H cube. So what am I asking, differentiate with time. You're asking rate of change of H. dV by dt, pi is constant. What is H cube ka differential? 3H square dH by dt. So dV by dt is nothing but the volume leaking per second. That is 10. This is 3 pi. And what is H? Question is given when L is 3 centimeters. When L is 3 centimeters, H is 3 by 2 centimeters. So H square is 3 by 2 whole square is dH by dt. So from here we get the rate of change of height would be 40 by 27 pi. Yeah, check. Again, let me explain the whole thing. Listen, the main catch here is, Mridul, keep your cam on. The main idea here is, the question is find dH by dt, rate of change of height. The only thing that I can see is L here, R का discussion ही नहीं हो रहा है. So you should know volume of a cone. So if you don't know this, then you're gone. But I'm sure you studied in school volume of a cone. So volume of a cone we studied as 1 by 3 pi R square H. Using Pythagoras theorem, let's eliminate R. And using this angle 60 degrees, you can eliminate L. So you converted the entire volume in terms of H. Once you got this, question is over. Please have a look at this. Have a look at the steps. Any doubts, ask me. Any doubts? Clear now, Om? Got this? Devansh? Devika? Soham? Tanish? Sanya? Clear? Archita? Arush? Perfect. What about this bird का problem? ये आया किसी को? 4.28, okay. You can leave the answer in terms of pi, 9/7. Okay, last time also someone told me this. Let's see. 0.9. We have different answers, right? Anyone else? Any other answers? Okay, let's see. So let this distance be x. Let this distance be y. It is just kind of like, this is actually the same as the previous question, the head ka question. So if I take this angle as theta, so tan theta is 10 by x plus y, the big triangle. It is also equal to 3 by y. So 10y is 3x plus 3y. So we get 7y is equal to 3x. So from this data, we can see here dx by dt. So whenever the bird flies, dx by dt is 3 meters per second, isn't it? Every second, x is changing with 3 meters. So what is the velocity of the shadow? Velocity of the shadow is rate of change of x plus y. But x is how much? X is 7, y is 3x by 7. That would be 10 by 7 dx by dt. And dx by dt is nothing but 3. So 30 by 7 meters per second. Please check. If you actually see this question in the previous one, right, there is no difference. This point P is the shadow of the head. So basically the head is the bird. You're getting it? So it was the same question. I just said bird and all to confuse you. So height of this bird is the height of the man. Bird is nothing but the head of the man. It is the same question. There is nothing changed except for that. Do have a look at this. Not sure how you got 9 by 7 and 0.9 though. Easy. So if you see actually differentiation का इतना कुछ है ही नहीं इसमें. It is not really a differentiation problem. The main thing is, figuring out the distances and stuff. Any doubts on this? Please ask me. Great. Next thing. Hope everyone has resolved the paper. We'll see end of the class. We'll be discussing the doubts. Next one is maxima and minima. Quite a useful one. We are going to see this pretty frequently in physics. Now, what is a maxima? Now, be careful. It is maxima. It is not maximum. So maxima is nothing but maximum value in a local region. That is the actual definition. To put it in simple words, now peaks. So whenever you're climbing hills or mountains, right, the peaks are called maximas. Minimas are simply minimum value in a local region. Basically, these are valleys. Meaning, suppose if you take a function like this, look at this thing. Every time the value peaks 1, 2, 3. These are maximas. 4, 5, and let's say if I take a curve like this, so this is 6. So in this thing here, 1, 2, 3 are maximas. That's what I'm saying. Don't get confused. Don't think maxima means maximum. 4, 5, 6 are minimas. And if you observe something here, did you see the value of 6, which is actually a minima, is greater than value of 1, isn't it? So maxima does not mean maximum or minima does not mean minima. So here, if you observe value of 0.6 is greater than 1, which is a maxima. So value of a minima can be greater than maximum. So there's nothing like it's a maximum and minimum. But luckily, in physics, at least 11th and 12th, we will not have this problem. Maxima means maxima, minima means minima. So in physics, generally, right, we will. So this is the actual definition, though. In our course, generally, maxima is maximum, minima is minimum, which is not true. But for us, na, itna max kafi hai, meaning for the kind of problems we do, it works out. So just keep that in mind. Now let's see in more detail about this maxima and minima. Everyone clear with this page? Great. So first thing, let's say what's the maximum. Now really try to understand. Mathematically, it is easy, but you should really know what we are doing. So maximum means what? Peak. Now when you're climbing a peak, observe something here. If you draw the tangents here, the tangents, right, they're becoming flat. Then it is like this. That means if you look at the slope is positive, less positive, 0, negative, and more negative. So from left to right, slope decreases. And at maxima, the turning point, the slope is 0. So these are the two data points. This thing actually kind of makes sense, you know. Whenever you take a turn, momentarily you come to rest. Think about it. If you're going in a straight line, if you're going straight and you want to come back without stopping, you can't take a turn. If you're going in a line, isn't it? So it's like if I'm counting numbers from, let's say, +5 to -5, without touching 0, you can't go to -5. That is the meaning of this. So whenever you're sloping this, so we observe as you go from left to right, the slope decreases. This is the first observation. Second observation, at maxima, the slope is 0. So this is your first condition. So whenever you want to find maxima, condition 1, the slope or the first differential dy by dx is 0. This is the condition 1. Condition 2, slope is decreasing. That means rate of change of slope is negative, but slope itself is dy by dx, meaning differentiation ka differentiation, double differential. This is your second condition. The double differential should be negative. If anything satisfies these two conditions, we say the point is minima. So condition 1 is slope is 0. Condition 2, the double differential is negative. Let me show you in applications how it looks. But for now, mathematically, just remember this thing. We'll see numericals mein how this works out. Do have a look at this. Clear with the maxima? How we located this? So 2 points, slope is 0 and the slope is decreasing. Slope is nothing but the tan of the angle made by the tangent. Initially, if it is acute and then it become obtuse. Arush, Archita, clear with that? Archita, clear?
Yeah. Sir, could you explain the condition for one?
See now, the slope is decreasing means what? The change in slope is negative. If you are decreasing, what is change? Chalo. If you are decreasing means what? 5, 4, 3, 2, 1. The final
Yes.
value is always smaller than initial value, right?
Yes.
So what is change? Negative.
Okay.
You get the point? If your final value is always less than initial value, that means the quantity that you have is always decreasing, isn't it?
Yeah.
If the numbers are 5, 4, 3, 2, 1, 3 minus 5 is negative, 2 minus 3 is negative, 1 minus 2 is negative. You're getting it?
Yes, sir.
So the change is negative. Meaning, what is d of slope? Isn't it the change? Change in slope with x. If you're decreasing, then what is change in slope? Negative. I hope everyone is getting the meaning of that. If a function ka value is decreasing continuously, meaning if you're, let's say you're going from 100, 90, 80, 70, and so on, and if I ask you what is the change, the final minus initial is always negative. Means the changes you're always decreasing by minus 10. So same thing, if you take for minima is your value. The angle is obtuse. The angle is less obtuse. The angle becomes flat, 0. Then it becomes acute. Then it becomes more. So here, if you look at the tangents, the slope is increasing. Meaning the value is like -3, -2, -1, 0, 1, 2, 3. So the change is always positive. So remember this valley, right? This is the minimum. This point is your maximum. So same thing, condition 1, slope is 0. So this is the reason why you need a second condition, because condition 1 will tell both are 0. So if the slope is 0, you don't know whether it is a maxima or a minima. Condition 2, slope is increasing. So the change in slope is positive. Slope itself is dy by dx. This is the second condition. So slope is 0 and the double differential is greater than 0 gives you minima. Slope is 0 and the differential is negative gives you maxima. Keep this in mind. So second condition is what will actually tell you whether it is a maxima or minima. Now this is all max. Now let's see how to use this. But please have a look at this and ask me if you're confused. But Archita, you got the meaning of the change in slope is positive and change in slope negative, right?
Yes, sir, I got.
Yes, no? Yeah. Anyone else confused with anything particular? Please ask. Clear? Let's see a question. Let me show you an example. Let's say I give you a function y is equal to x square minus 3x plus 2. So I want to find maximum or minimum value of y. I don't know whether this has a maximum or minimum value. Maximum or minimum, any one or both. So this is what we do. Step one, for a maxima or a minima, the condition one is dy by dx should be 0. So dy by dx is 2x minus 3 is equal to 0. X is equal to 3 by 2. What does this mean? This means at x is equal to 3 by 2, we may have maxima or minima. I don't know. Because for both of them, the condition is same. Are you getting it? The meaning of the differential is that x is equal to 3 by 2, the value is going to maxima or minima. Step 2, double differential d square y by dx square. That means differentiation ka second differential again. This is dy by dx. Huh? So this is d by dx of 2x minus 3. So how much is this? This is 2. So the second differential d square by dx square is equal to 2 is greater than 0. If the second differential is positive, means what? It's a minimum. So at x is equal to 3 by 2, the value is minimum. And what is the minimum value? So therefore, y minimum, you have to put 3 by 2 ka value there. So 3 by 2 whole square minus 3 into 3 by 2 plus 2. This is 9 by 4 minus 9 by 2 plus 2. That, that would be minus 9 by 4 plus 2 minus 1 by 4. Now, the graphs are not important, but if I try to show you this on a graph, this is the meaning of this graph. This function actually looks like this. At this point, x is equal to 3 by 2. The function ka value will go to y is equal to minus 1 by 4. So this point is minimum. Are you getting the geometrical interpretation? So this function, if you draw y is equal to this graph, it looks like this curve, the U shape. It's a parabola basically. So at x is equal to 3 by 2, we are getting a minimum value minus 1 by 4. Basically, it forms a valley at 3 by 2. Are you getting the interpretation of this? Now, every time you won't be able to draw a graph, but the mathematical part will tell you the answer. So in this case, there is no maxima. Obviously, both are going to infinity. There is no peak only anywhere. There is no maxima point here. There is only minimum here. Are you getting how I approached? Now, again, be careful here. What did I ask you? I asked you the minimum value of y. So x is equal to 3 by 2 is not the answer. X is equal to 3 by 2 is the point where the value goes to minimum. How much is that minimum value? Minus 1 by 4. Did you get that? Have a look at this page. Let's see one more like this. Yeah, let's see. Now you guys give it a try. Y is equal to minus x square plus 5x minus 6. Find maxima or minima of y. Hmm. 49 by 4 maxima. Okay, anyone else got the answer? We have one answer. 49 by 4. Okay, we have two 49 by 4s. Looks right. Tanish, Shashwat, what 49 by 4? Anyone else got an answer? Please make sure to type your answers. Yeah, I think most of you got the same. So steps are the same. Step 1, differentiate. Minus 2x plus 5 is 0. So x is equal to 5 by 2. So there is a maxima or minima here. Step 2, differentiate this guy again. Meaning 2x minus 5 can differentiate minus 2, which is less than 0. That means that x is equal to 5 by 2. We have maxima. We're not going to write all these steps later on. So y max will be, substitute 5 by 2 minus 25 by 4 plus 25 by 2 minus 6. How much is this? 25 by 4 minus 6. 1 by 4. 1 by 4, na? How did you guys get 49 by 4? Right, Om. You're right. So if you plot a yx graph, like I said again, it's Maximus will teach you how to put graphs, but basic idea you should have. So at a point x is equal to 5 by 2, you're reaching a peak value at 1 by 4. So the graph is something like this. So at x is equal to 5 by 2, your peak value is 1 by 4. This is how the graph would have looked. Please check. Clear? They won't ask questions like this. This is all max part. Let's see something more, little more complex. Turn in the page. Let's say y is equal to x cubed by 3 minus 3x square by 2 plus 2x plus 1. Now find maximum or minimum value. This is slightly little weird, the double differential. But you give it a try for a minute or two, then I'll show you one and then I'll give you one more. Step 1 is same. What is step 1? dy by dx, which is x square minus 3x plus 2 equal to 0. Now we get x is equal to 1 and 2. We got two roots. Matlab, one of them is maximum, one of them is minimum. Or both maxima, both minima. We don't know. But if you think about logically, right, there is no way you'll get two maximas. Why? When you reach a maximum, if you want to go to the next value, you just can't keep going up without coming down. Philosophically, right, it means like this. In life, now you can never be happy continuously. You'll be happy, then there'll be something bad, and then you'll be happy, then you'll be something bad. Same way, in your life, you can't keep on going down. At one point, you have to keep going up. You cannot have continuous minimas or continuous maximas. So, step two, now this is where it is a little different from the normal. Double differential, d square y by dx square. This guy would be 2x minus 3. Okay? Now, this is how you check. Now you substitute the value. Sorry, x is equal to 1. So directly you're not getting positive and negative. You have to substitute 2 into 1 minus 3 minus 1. This is less than 0. Meaning this is what? Maxima, na? So if the double differential equation, if there's an x value, then you have to substitute this x is 1 is equal to 2 and 1 and 2. And then you have to check whether it is positive or negative. In the previous problem, luckily, right, you are getting the value whether it is positive or negative directly. Every time it won't happen. So the double differential d square by dx square. This guy will be 2 into 2 minus 3 is plus 1 is greater than 0. So this is minima. That is how you figure out. In case your double differential has x ka term inside it, then you have to substitute the x ka value and see whether it is positive or negative. So your y maximum occurs when x is equal to 1. Substitute the value. 1 by 3 minus 3 by 2 plus 2 plus 1, that is 3, 3 by 2, 3 by 2 plus 1 by 3, 9 by 2, 11 by 3. 6 actually. 3 by 2 plus 1 by 3, 3, 3, 9, 9 plus 2, 11, yeah, 6. Y minimum occurs at x is equal to 2. 2 cube by 8, 8 by 3 minus 3, 2, 6, 4 plus 1, that's minus 1, so 5 by 3. Right, Vihan, right home, that's your answers. Now, how to draw this? It's difficult, it's a cubic function. All that I know is the function will have some maxima, minima. So if I try to draw also, x is equal to 1, x is equal to 2. I know there is a peak here. I know there is a minima here, and this must have gone like this. And this must have gone like something like this. I won't say this is the exact graph, but something like this. So there's a maxima and there's a minima. These are just a random I draw. You can only talk about the peaks and values. Clear with this? Understood? So if you have a cubic function, this is what you do. Anyone has a doubt in the process? Anya, clear na? Mridul, Devansh, Brijesh. Now you guys do the same one. I'll give you similar one. Y is equal to x cubed by 3 minus 5x squared by 2 plus 6x plus 1. Find maximum or minimum value of this thing. Same thing, I just change the numbers. Same thing, step 1. dy by dx. X square minus 5x plus 6 is 0. X will be 2 and 3. Double differential will be 2x minus 5. At x is equal to 2, the double differential, this guy would be less than 0. So this guy is a maxima. At x is equal to 3, the double differential is positive. This is minima. So y max will occur when x is equal to 2. Substitute the value, I'm leaving it to you. Phi minimum will occur at x is equal to 3. Substitute, you'll get the answer. Clear? You can do the value substitution. Easy? Let's see one more. Y is equal to x plus 1 by x. Find maxima or minimum value of y and approximately plot the graph. So for this function, try to plot a graph. The graphs is something which you should have a rough idea, meaning they won't expect you to draw exactly, but a rough estimation to होना चाहिए. This is a good one. You will never see this in physics, but there is a thing I wanted to show you. Just give it a try, get some water and come. Any answers? See. Step 1, differentiate. That would be 1 minus 1 by x square. If you put equal to 0, you'll get x is equal to -1 or +1, isn't it? There are two values. X is plus or -1. Now we are confused which one is maximum, which one is minimum. Again, double differentiate this. So d square by dx square, 1 ka differential is 0. 1 by x square differential is -2 by x cube. So if you substitute x is equal to -1, we have d square y by dx square is -2, which is less than 0. So this is actually a maximum. At x is equal to +1, d square y by dx square is +2 greater than 0. This is actually minimum. So y maxima occurs at x is equal to -1, that is -1, -1, -2. Y minima occurs at x is equal to +1. There's actually +1, +1, +2. Did you notice something? Maxima is -2, minima is +2. The reason for this is, if you plot the graph, you'll understand. Say, again, how to plot a graph, I'll give you a rough idea. Listen carefully. So you're drawing y is equal to x plus 1 by x. Just think about it logically. See here. If you put x is equal to 0, what am I getting? Infinity, right? If you put x is equal to 0, 1 by x will go to infinity. If I keep x as infinity, then this will go to very big value. That means the value, when you're very x is closing to 0, you'll be at infinity. When x is very big, again you'll go to infinity. This is how the graph looks. Similarly, when you go to negative value, the graph looks like this again. Sit straight now, Devansh. Don't do yoga stretches and all. Everyone sit straight, focus. This is how the graph looks. Something. Yeah, this is better. So now if you look at the values here, this guy is x is equal to 1. This value is 2, and this is a minima, isn't it? That's what I said. Maxima is not maximum, minima is not minima. This point here, when x is equal to -1, this is -2, this point is maximum. So peaks are actually maxima, minimas are actually valleys. But in physics 11th and 12th, it works out for us. Maxima is maximum, minima is minima. I hope you're getting this. So I want you to know the actual concept, but I want you to know, like, it works out for physics. Any doubts on this, please ask me. So this is how you plot a graph. You can check. If you put x0, this is 0, but this is 1 by 0 is infinity. If you put x infinity, this is infinity, 1 by infinity is 0. That means this value will blow off on both the sides to infinity. So on both the sides should go to infinity, in the center it will dip. Same thing with the negative also. Anyone confused with the diagram, please ask. Clear? Now, let's see something else. So later on, we will see in electrostatics and all, we'll have questions like this. There is a charge q here. There's a charge q here. We'll put a -q charge here at a distance x, and the distances are d and d, something like this. So don't worry about all that stuff. So this plus q will attract like this. This plus q will attract like this. So force on charge small q is given by F is equal to some constant x by c into x by x square plus d square whole power 3 by 2. C and d are constants. How did we get this function? Don't worry, that's a different chapter. So the question is, find x for maximum force. This is how they'll ask you in the exam. Meaning, I'll show you one question. Say how we did this recently. There were 6 charges like this, an hexagon. So when the cube is taken above, all the 6 charges are attracting the small q. Then we derive this now. There, look at the function here, how we got this function here. 6k y by a square plus y square 3 by 2. All this is constants anyway. Question y tha, find the maximum value of y for maximum minima. So we have to differentiate and equate to 0. So maximum minimums will come like this in some part of the question. So they will expect you to figure out this function and then solve. But for now, I'm giving you the function, so don't worry about that. So find the maximum value of force F. I'm not asking maximum value, I'm asking X. At what value of X you get maximum force? Try. I hope you got the question what I'm asking. So we have 2 charges D. That is just all a story. You don't need all that actually. But I'm just trying to show you like how they'll frame questions in physics. So that force on that small q. So this will be the net force. So that value will come something like this, C into X plus X square plus D square 3 by 2. So for what value of X, the force on the charge will be maximum. Meaning if you put this charge at different positions, right, you'll get different forces. So there's one particular distance X where they'll attract with the maximum force. Indirectly, I'm just asking you find the maximum value of this function. That's it. Try. First differential 0. Actually, you'll get the answer with one differential. One thing in physics, right? Advantage is they'll ask you find the maximum force. After first differentiation, whatever you get is the maximum force. So there's no need to do second differential. That is one advantage you have. Generally, kya hota hai na? We are confused whether it is maximum or minimum. But if the question is find maximum, what you get is maximum only. So just differentiate and equate to 0. So f is cx by x square. You know how to differentiate this. I taught you. There. See, I told you this will come. Is this how we differentiated? X by x square plus 2 whole power 3 by 2. So this can be written as c into x square plus d square whole power minus 3 by 2. I'll use product rule. So df by dx, c is anyway constant, so just keep it outside. So it will be x differential of x square plus d square whole power minus 3 by 2 plus x square plus d square whole power minus 3 by 2 into dx by dx. Generally, I don't like division rule. Every time the question comes, I will change into product rule and do it. But if you want division rule, you can do it. Nothing wrong. I don't prefer. I like to keep everything in product rule only. So differentiate this thing. So C is anyway outside. Throw it out. X and this guy is how much? Minus 3/2 x square plus d square minus 5/2. And don't forget, you have to differentiate whatever is inside. This is something to the power of minus 3/2. Then you differentiate whatever is inside. So that is again x square plus d square. This is x square plus d square minus 3/2. That is 1 anyways. So C, that is 2x. 2 will cancel. You will end up with minus 3x square by x square plus d square whole power 5/2 plus 1 by x square plus d square whole power 3/2. Now you're saying equate to 0. So if you equate this guy to 0, you end up with 3x square by x square plus d square is equal to 5/2 is 1 by x square plus d square whole power 3/2. So that is 5/2 minus 3/2 is square only. So 3x square by x square plus d square is equal to 1. That would be 2x square is equal to d square. We get x is equal to d by root 2. That's your answer. Set this distance x is equal to d by root 2, you get a maximum force. And if you actually see this question which we did, it was the same answer. A by root 2. So this is how they'll ask the questions in maximum minima. No one will ask you to find the maximum value of some function. They'll expect you to first figure out this function and then differentiate. But anyways, right now I'm showing you how to get this. Clear? There's no need to do second differential because they asked you for maximum, meaning it should be maximum only. Don't worry too much about it. Generally, it works out. Clear? I hope now you got the use of this differential. Now, this is all little mathematical. Now, let me show you how you can get practical questions actually. Like I said, the calculus part is the easiest one. The headache is converting a problem into calculus. Any doubts on this page? Please ask me. Clear? Next one. See. In an orchard, there are 50 apple trees. Each tree produces 8 apples, 8 apples per year. So you have a big apple orchard and each tree is producing 8 apples per year. So then you felt like, yeah, itna apples are hai, so you became a little greedy. So you started planting extra trees. Now for every additional tree that you plant, the production decreases by 10 apples per tree. This actually happens when you put a lot of trees in the same space, they start fighting for resources. Getting it? They have a limited soil, limited resources, limited sunlight. So production actually drops. Again, listen to the story. There are 50 trees already. Each tree is producing 800 apples. So if you plant one more extra tree, kya hoga? Production kya hoga? Initially, you have 50 trees into 800. Na? The moment you plant one more tree, you have 51 trees, but the production has become 790. You're getting all the trees in the orchard will produce 10 apples less. You're getting my point? But this one extra tree is producing 790 apples, isn't it? So that is a profit. So the question is, how many more trees can be planted to maximize production? So if you want to get maximum number of apples, how many more trees can you plant, or should you plant? If you get too greedy and plant too many plants, all the plants will die. You'll get zero production. Now see, in this, there is no max, nothing. It's a proper verbal question. But this is a maximum minimum question. Try. Anyone is confused with the diagram, the question, please ask me. How did you get the equations? First, creating the equation is the headache part. Let me help you here. So let the production be P. So you have to create variables. Let the number of additional trees be X. Right, Arush. So production P is nothing but number of trees into production per tree. I hope everyone agrees with this statement. So your production P is number of trees is 50 plus X. And for every one tree, your production decreases by 10. Shashwat. But the question is number of extra trees, na? Total nahi. So initially producing 800. For one tree, you lose 10 apples. For two trees, you lose 20 apples. For X trees, you lose 10X apples. I hope this is making sense. So the production P becomes now 40,000. That is 800 minus 500. So plus 300X minus 10X square. There, you got an equation. So you got P in terms of X. So अभी इसका maximum इनका करना है. For maximum, dP by dx is equal to 0. That is 300 minus 20x is equal to 0. X is equal to 15. That's what I said. The differentiation is actually the easiest one. Headache is getting the equation. So when you plant 15 trees, you get maximum production. If you actually try to plot a graph of production versus X, initially you're producing around 40,000 apples. And when you plant 15 trees, the production will peak and then it starts dropping again. So if you actually substitute the value of 15, I think you get around 42,250 apples. You produce extra 2,250 apples extra, you'll get. But if you become too greedy and go more than 15, the functions will start dying actually. The plants will produce less apples. Have a look at this. Clear? Now, are you getting calculus is actually easy? The problem is something else. Let's see one more like this. Any doubts on this page? Please ask me. Brijesh, Archita, clear? Sania, Devansh, Tanish, clear, na? Soham, Pushkal. Perfect. Next one. This is a good one. We have a lake. Ten kilometers wide. So we have point A here. We have point B here. We have point C here. B to C is also 10 kilometers. So now we have a person here. So velocity of the man when he's running on the ground, he can run with a speed of 5 kilometers per hour. But the same person, when you tell him to swim, swimming is more difficult. Speed actually decreases 3 kilometers per hour. Now this person wants to go from A to C. Find the minimum time taken to go from A to C. Now listen to the scenario here. I'll tell you what is happening. Now how can you go? You can directly swim and go, right? You can directly swim and go, or you can go to B and then you can run because running is faster. Even though the length becomes more, the distance, or you could go somewhere in the middle and then you can run. So there are infinite ways this person can go, isn't it? But among all these paths, there is one path with the least time. I hope you're getting the sense. If you go in the water, this is the shortest path, but the problem is speed is less. If you try to go to the land and run, the distance has become too much. That means somewhere in the middle, there's a compromise. At some particular position here, if you can reach and then run, it will save you the time. That means if you're, let's say you're trying to send passengers from A to C, I will use a boat from A to C, then I'll put a bus for them to go. That will take the passengers in the shortest time than taking them directly in the boat. I hope the question is making sense now. So we don't know how this person is going. He can go in infinite ways. But among all the paths, there is one path with the shortest time. Water is at rest. Lake, na? It's not a river. Try. These are the kind of questions you'll get in the exam. So forming an equation is the headache now. Think I'll give you 2-3 minutes. Can we like run on? You can do that also. Same thing. You can first run on the ground and then you can swim. Matlab, you're saying you'll do like this. That is same as actually going like this, isn't it? Same thing. Doesn't matter. You can first swim or you can run. Do anything you want. But swimming and running is better because at least you'll get your clothes will get dry. 16 by 3 hours. I don't remember the answer, but I don't think so. 16 by 3. Okay, we have one answer. Anyone else got 16 by 3? I don't remember the answer. 16 by 3, that is almost 5 hours, right? 10 root 2 by 3. No, it is definitely wrong, Ashwath. Because see, I'll tell you why. If I just go straight, chupchap sab chhod ke straight gaya. Distance is how much? 10 root 2 by 3. Root 2 is 1.4, so that is around 14 by 3, right? Your answer is still bigger. Same thing. Dekho, wahi logic hai. You're getting it? I can clearly tell your answer is wrong without doing anything. Chupchap, if you go swim straight also, you'll get 14 by 3. Means your answer is less than this. If you're getting anything more than this, you're definitely wrong. Let's see. So listen carefully what you're going to do. We don't know how this guy goes. So that is always the story. We don't know how he goes. So let him go till here. Let this distance be x. Let's call this point D, and then let him go from here to here. Make sense? That means for different values of x, you get different positions, no? If I put x is equal to 0, means he went like this. If I keep x is equal to 10, means he went like this. Are you getting? By changing the values of x, I get different paths. Are you getting this? So whenever you create an equation, that's what you do. You have to create a variable such that for different values of that variable, you get different paths. So the time taken here will be how much? Let the function time, capital T, would be AD. The speed on the water is 3 plus dc by 5. Any doubts on this equation? So this equation time AD using Pythagoras theorem root over 10 square plus x square by 3 dc is nothing but 10 minus x by 5. There, did you get the equation? You got the time as a function of x. For different values of x, you get different paths. So we need to minimize this function. For minima, dt by dx is equal to 0. Differentiate this, how much you get? 1 by 3. That is something to the power of half. So half into 10 square plus x square whole power half minus 1, so minus half. Then differentiate whatever is inside, you get a 2x extra. This guy is 10 minus, so 0 minus 1 by 5. This is x by 3 root over 10 square plus x square minus 1 by 5. This should be equal to 0. So 5x is equal to root over 3 into 100 plus x square. Square on both sides. 25x square is 900 plus 9x square. X will be 900 by 16 ka root. That is 30 by 4. 7.5 kilometers. That means this guy has to go, he has to land on a point which is 7.5 kilometers from B. So you're done actually. Once you got this, so take this time and put it in this. So for the minimum time, it will be root over 100 plus x ka value is 7.5. That is 225 by 4. I'm writing as 15 by 2 by 3 plus 2.5 by 5 that is 625 by 4, that is 25 by 6 plus this is half. Multiply 3 and 3, 28 by 12. 20. 28 by 6. 14 by 3 hours. Make sense? This is definitely less than this. This is 10 root 2 by 3, which is 14.1 something, no? You got less than that. So this person has to, so how much is he running on the ground? This is root over 10 square plus this. This is 12.5 kilometers. So he's running 12.5 kilometers swimming in the water and he's going 2.5 kilometers in the land. So in total, this guy has gone 15 kilometers. Please have a look at the steps. Again, did you observe one thing? What is the most difficult part? This one, right? Creating that equation was the most difficult part. Once you got that, it is done. You have to just differentiate and finish it off. These are the type of questions we'll actually, applications will be like this. Have a look at this. Clear? Let's see one more. Any doubts on this page, please ask me. Clear, na, Arush? Devika? Om? Shashwat? Great. Next one. Let's say you're a shepherd. You have a lot of sheep. And you have a big farm also. In that farm, you have a hill. So you went to the place and you bought a big fence. So you want to create a fence for the sheep to stay. So a fence of length 100 meters is used to construct a rectangular fence. You want to create a rectangular enclosure with 3 sides. So luckily on your farm, there is a small hill. And the 4th side is blocked by a hill. So that side, there's no need to put a fence. So this is a hill. So you went and you created a fence like this, 3 side. So we have our beautiful sheep here. There. So the sheep are not escaping the fence. So I gave this question last time. Someone is like, sir, what if the sheep climbs the hill and jumps off? I said, let the sheep die. I don't give a damn. That's not the question. Okay. So if the sheep run away, then the farmer will realize and he will do something about it. So the question is, find the maximum area of the enclosure. Now understand one thing. When this guy is constructing the fence, he can do it multiple ways. One second. So that means this guy can create a fence in multiple ways. You can make a very long fence like this. You can make this kind of fence. You can make fence like this. You're getting, there are different shapes he can make. But among all the shapes, there is one shape which will give you the maximum area. Get this? It's a rectangular fence. You have to prove it, Rom. We are not an astrology class. You have to prove with the answers. Don't use astrology. Your feelings, your astrologies, all these are wrong. Don't do that. Okay, Devika got something. Okay, did you prove it or feeling? Don't use feelings. Prove it. Next question, use your feelings. मैं देखता हूँ कितना feelings आएगा next question का answer. अरे if you are feeling so much, why didn't you feel for this one and give me the answer? इसका भी feel करना चाहिए था ना. चलो try. I'll send you a sheet based on all this today. Let's see. Right, Sanya. Devika, you got the answer though. So look at the idea here. When you made this fence, let the length be L, let this be B, and let this is B. So the main idea here is what is given is what is given here? The perimeter is given. The perimeter is constant. The perimeter, which is L plus 2B, is 100. The area is L into B. So you want to maximize this. But the problem, there are two variables. So eliminate them. So L can be written as 100 minus 2B into B. So the main job in this is, if there are two variables, create one single variable from it. So we got A in terms of 100B minus 2B square. Then you're done, maximum minimum. So dA by dB, here B is the variable, is 100 minus 4B is equal to 0. That means when the breadth is 25, obviously L will be 50. You get the maximum area. So max area will be 1250. Got this? Suppose if you don't have the fourth side, then what would have happened to the question? You have to construct all the four sides. Getting it? Then actually you'll get a square. And then the area will be 625. Did you observe one thing? Just by eliminating one side, you made the area double. If you had to make all the four sides, you'll get only 625. The moment you eliminated one area, one variable, one side, you got a double area. All clear with this? Easy? Let's see one more. We have a sheet. A metal sheet of area 100 meter square is used to construct a cylindrical water tank with open top. So you want to construct a tank like this water tank. So on the top, it is open. So the question is, now see, how can you construct the tank? You can construct a tank like this broad one, or you can construct a tall tank. You can do multiple ways of constructing a tank, isn't it? Now, among all the tanks, there is one tank with the maximum volume. So find the maximum volume of the water tank. Think about it. If you want to make a tank, don't you want to make maximum volume? Find the maximum volume of water tank. Assume there is no material wastage. Somehow all the material is used. So you have the sheet ka area. So you have to take this sheet and make a water tank. The bottom is also sealed. You have to make the bottom part also. So you have to make the base to banana hai. The top you can leave it. You're not closing it. In case you don't know, I'll give you some information. Volume of a cylinder is pi r square h. I hope everyone knows. R is the radius, h is the height. The curved surface area is 2 pi r into h. So this much you should know geometry. In case you don't know the shapes and volumes, right? In the booklet that I gave you, booklet 1, there's a section C. Check it out. It has all volumes, areas, and lengths and everything for different shapes. You should know the results. Give it a try. How do we do this? CS area does not include the base. The curved surface area is only this outer part. R is 50. Give me the volume record. Why am I asking? Why are you giving me R? R 50. इतना अच्छा आंसर कैसा आ गया है? That much I know. It's not such a good answer. Definitely not an answer. तो सोचना लॉजिक है. देखो ओम, अगर R50 है तो बेस का जो शीट था उसका एरिया पाई आर स्क्वायर, दैट इज बिकम 2500 into पाई. तेरे पास पूरा एरिया मिला के 100 है. You created a sheet of 2500 pi. Either you have some superpowers where you can create extra material, or you're using some alien max where people on Earth cannot understand, or you did a blunder. So you can choose the option whichever you like. So we people on Earth are primitive humans. We can use only basic max. So please don't use this higher dimensional max. Happens. One becomes gray, one becomes 2. You know how to make 1 is equal to 2? Kabhi kiya? See, let A is equal to B. Multiply both sides with B. AB is equal to B square. Subtract both sides with A square. Take out A common. B minus A into B plus A. So A is equal to B plus A. But I already know A is equal to B. Therefore, 1 is equal to 2. There, I proved 1 is equal to 2. See. Can someone tell me what shit I did? Where did I mess up? Or 1 is actually equal to 2. I'm using some alien max. What the hell did I do? Where did I goof up? Itna to clear, I goofed up. Definitely I goofed up. You can't go into come and say 1 is equal to 2. हाँ, right, Arush. हाँ, वो तो है विहान. Others, what do you guys think? Cancellation part. B minus A is 0. I cancelled 0 and 0 here. Isn't it? It is like writing 0 into 2 is equal to 0 into 3. 0, 0 cancel ho gaya, 2 is equal to 3. Understood what I did? You're not supposed to cancel zeros on both the sides. But the 0, right? Smartly, we have hidden it here in B minus A ka term. So people don't think we're actually cancelling 0. The mistake was this part. So 1 is not equal to 2. I goofed up. That's what it means. Let's see how to do this thing then. So what did I give you here exactly? I give you the surface area. Look at this thing. Total area of the sheet. So let's make a cylinder here of radius r and height h. So if we take the total surface area, we have 2 pi r h, the curved surface area, plus pi r square. So and this is 100. Are you getting it? Now the volume is given by pi r square h. Now this has nothing to do with the open top. Again, problem ye tha, there are two variables here. So we need to eliminate one of them. So it is 100 minus pi r square by 2 pi r. Take this and substitute here. So we have volume is pi r square into h is 100 minus pi r square by 2 pi r. Pi r will cancel. One r will be left out. So this guy would be 50r minus pi r cube by 2. Hope I did right. Pi and r will cancel. 50 and pi r by 2. Yeah. Check. So basically, so in all these questions, the main idea, you know what? You always have two variables, r and h, L and B. You have to create the volume in terms of one variable. 50r minus pi r cube by 2, maximum minimum. So dv by dr is 50 minus 3 pi r square by 2 equal to 0. So r will be 100 by 3 pi ka root. So if you keep this radius ka value, you get maximum value. So v is equal to v maximum. So simply take this guy and put it in this function. 50r, which is 100 by 3 pi minus pi by 2, 100 by 3 pi by root over 100 by 3 pi. Pi will cancel. That is 50 by 3. 50 minus 50 by 3 is 50 minus 50 by 3 is 200 by 3. So 100 by 3 pi root over 100 by 3. I hope I didn't give up the calculations. This pi will cancel. That is 50 by 3. 50 minus 50 by 3. Yeah, that looks right. Check. So in all these questions, this is the theme. They will give you something in terms of two variables. They will ask you something in terms of the same two variables. Area is given in terms of r and h. Volume is given in terms of r and h. So eliminate one variable, you'll get v in terms of r. Differentiate, finish it off. See, once you got to here, question is over. It's all max from here. So the main headache is creating that equation in terms of r. Please have a look at the steps. Pi got cancelled. Pi cancel हो गया ना? सही बोल रहे हो. 100 by 3. Yeah, I did a mistake. Clear the steps? This is how applications will look in differentiation. Getting it? So with that, we are done with the differentiation part. So next class, when we catch up, we're going to start off with integration. I will be sending you a small sheet on this thing, 10, 15 questions, something like all these very weird kind of questions. So this is how I want you to learn calculus. Differentiate. That is all bullshit. This Max Fuel also will teach you. Getting it? Differentiating all weird functions. That is not important for us. The main headache is these kind of problems, where you have to create a situation and solve. This is actually how you learn calculus for physics. Unfortunately, you'll not find anything in any book like this, because this thing read over this last 1 decade or something, I collected all questions and I made up like this. So, but generally what I observe now, when they teach calculus, what physics people do, they take questions from maths and give it directly, which is of no use for us. So, okay, anyway, so I'll send you a small sheet on this thing. You can work on that. So next class, when we catch up, right, we'll be starting off with integration. So this week a test, right, will be online tomorrow. You have differentiation only basics, what I did before the vacation. Okay, maximum minimum applications are not there. So basic differentiation, basic max, and you have vectors completely. So the test will be online tomorrow. So I will post in the group anyways. Okay, so with that, we'll wrap up for the day. So we will see the paper cut doubts, but first let's see any doubts in today's class notes, and then we will see the exam paper.